Welcome back to Logic and Set Theory. We already learned about conditional or implication. And today, we are going to cover converse, inverse, and contrapositive of a given conditional. And let us see which of these three is equivalent to the given conditional. Let's get started. A conditional is usually written in if-then format. Just like in this example, the if part is what you call the premise. And then the then part is referred to as the conclusion. In this sentence, if -4 is even, then 0 is even. -4 is even is the premise, and 0 is even is the conclusion. We can use P to represent the premise and Q to represent the conclusion. Thus, this statement can be written as P implies Q. Remember that P and Q are variables and we can use any other variables to represent the premise and conclusion respectively. We can use S or R. Also, we can interchange the symbols. That is, Q can be the premise and P can also be the conclusion. If -4 is not even, then 0 is not even. In this sentence, I negated P and negated Q. And so in symbols, we can write this statement as not P implies not Q. If 0 is even, then -4 is even. In this sentence, I interchange the premise and conclusion of the original conditional. In symbols, I can write the statement as Q implies P. The next sentence is, if 0 is not even, then -4 is not even. I simply use the negation of Q as the premise and the negation of P as the conclusion. In symbols, we write not Q implies not P. From P implies Q, we now have not P implies not Q, Q implies P, and not Q implies not P. Which of these three is equivalent to P implies Q? Let's find out. Recall that the conditional is false if the premise is true and the conclusion is false. Otherwise, the conditional is considered to be true. This truth table can help us determine the truth values of the different conditionals that we have just identified. We now have a table with columns for P, Q, P implies Q with the corresponding truth values, true, false, true, true. Also, we have columns for not P implies not Q, Q implies P, as well as not Q implies not P. And for the last three columns, we need to have not P and not Q. Remember that not P implies not Q, Q implies P, and not Q implies not P are also conditionals. They are also implications. Just like P implies Q, which is obviously a conditional. Let us now fill in the table. For the column not P, we just have to refer to the truth values of P and negate these truth values. So true becomes false, true becomes false, false becomes true, and false becomes true. So we have false, false, true, true for not P. For not Q, you just have to refer to the second column and negate that. We have false, true, false, and true. Remember that the order of the truth values in these columns may differ, and that depends on how you have placed the truth values of P and Q respectively. So if you're going to construct your own truth table, your entries may look slightly different in terms of the order. Let us now focus on the column for not P implies not Q. We need to refer to this particular row wherein not P is true and not Q is false. This is the only case when not P implies not Q is false. The rest would be true. For the column intended for Q implies P, we also have to refer to the first two columns, Q and P. So just remember that the case when Q is true and P is false, that's the only case when Q implies P is false. There, the third row. So let us indicate that to be false. The rest should be true. That's easy, right? And now we are in the last column. Not Q implies not P. We have to refer to the column for not Q and the column for not P. We have to look for the row wherein not Q is true and not P is false. So that's the second row. True implies false is considered to be false. So let's write it here, false. And of course, the rest must be true. Remember that the last three columns are also conditionals. Specifically, not P implies not Q is what you call the inverse of P implies Q. Q implies P is the converse of P implies Q. And the last column, not Q implies not P, is the contrapositive of P implies Q. Observe that some columns have the same entries. Let's take a look at the third column. P implies Q. The entries are true, false, true, true. These truth values are the same as the truth values of the last column. That means that P implies Q and not Q implies not P are logically equivalent. Take a look again at the truth values. Observe that not P implies not Q with truth values true, true, false, true have the same entries as Q implies P. That means that these two statements are logically equivalent. These are the big ideas that we need to remember. The conditional and its contrapositive are logically equivalent. In symbols, P implies Q is equivalent to not Q implies not P. Also, the inverse and the converse of a given conditional are logically equivalent. In symbols, we write not P implies not Q is equivalent to Q implies P. Now let us go back to the sentences that we had a while ago. Which of these three sentences below is equivalent to if -4 is even, then 0 is even? Definitely the given conditional here on top is equivalent to the conditional here below, which is the contrapositive of the original conditional. Also, if -4 is not even, then 0 is not even, is equivalent to if 0 is even, then -4 is even. Now let us try this. Let us write the converse, inverse, and contrapositive of the given statement. If you are vaccinated, then you are less likely to experience hospitalization. Please share your answers in the comments below.